So sample problem 1.4 continues with our use of unit conversion to answer questions. This one again has nothing to do with chemistry, but we are beginning to think about some chemical properties such as volume and so forth. So with this problem, I'm going to introduce something that I sometimes will use when we work through problems, which is just to draw a picture because it helps us understand what's going on. So for this problem, we're going to have a graduated cylinder here that has some water in it. And it has 19.9 milliliters of water. We're going to add a little piece of metal here into our graduated cylinder. And then when the graduated cylinder now has our water and our little piece of metal, the volume is now 24.5 milliliters. What we can do is take the difference in these two measurements of water, this displacement of water, and use that to determine the volume of an irregular piece of metal. So the volume of the metal is going to be equal to the volume of the water final minus the water that we started out with. And this is a big theme that we are going to see from time to time throughout here in this course, is that we're going to see a final measurement minus an initial measurement. And that's going to become important as we do a lot of change sorts of calculations. So in this case, the difference in the volume that we have here is 4.6 milliliters. So 4.6 milliliters is the volume of the galena in milliliters. But the problem asks us, what is the volume of the piece of galena in centimeters cubed and in liters? So let's take the conversion of milliliters to liters first, because that might be the easiest one to kind of think of conceptually, because we've talked about these sort of unit prefix conversions. And I'm going to take this sample problem as an opportunity to highlight some important things to think about with using these prefix conversions. Now remember, when we're doing unit conversion, if we have milliliters and we want to convert to something else, we want milliliters to go away. So right now milliliters is in the numerator and I want milliliters to go away, so I'm going to put milliliters in the denominator. The first question I'll ask myself is, do I have a direct relationship between what I have, where I am, milliliters, and where I want to go, which is liters? And the answer is yes. We've got a direct relationship between milliliters and liters, and it's a prefix conversion. It's a factor of 1,000. Now, here is a problem where often students will make mistakes. I'm just going to kind of highlight this right here, that it's very common for students to make a mistake in terms of where the 1,000 goes or where the 1 goes and so forth. There's actually 4 ways we can think about this conversion, and I'm going to come over to the side here just for a moment. We need to find out a relationship between milliliters and liters. And again, we know it's 1,000, but we don't know which one goes where. So the first thing that we have to remember is this concept that we're always going to have something that's big with something that's little. And so one of the things that you do sort of have to remember is when we're looking at units, which unit is the bigger unit? Well, this one might be a little bit easier to think about because we sort of have things in our world that we can think about, right? We can have a liter of soda. We can have a certain small volume that we measure in milliliters. So that's an easier one to sort of think about. But if we think about it this way, the big unit is liters, the little unit is milliliters. When we put a 1 in, if we put a 1 in with a little value, that must mean that that value, that number, is big, which must mean we put a little number over here. And so what that allows us to do is say that we can't have 1,000 over here. We can't have 10 to the third. It must be 10 to the minus third. So, and remember, I told you a milliliter is about the size of a sugar cube. So always keep a little sugar cube in the back of your mind and think about a little sugar cube. And this is saying if we wanted to think about the volume of a sugar cube, it might be 1/1000th of a liter bottle of soda. And that sort of makes sense. Taking this one step further, we could also think of another unit conversion that puts the 1 on the liter side. So again, if liter is the big unit and milliliter is the little unit, and we put a 1 over with the liter, that must mean we have the bigger number over on this side, which means that's going to be the 1,000. So thought of another way, if we have a full 1 liter bottle, we can fit 1,000 sugar cubes in there. So a little side note here, just to kind of highlight the importance of making sure that when we do these prefix conversions, because this is a common place where students will make mistakes and they'll have the wrong number with the unit. And so we need to make sure that that's correct, because otherwise you'll be off by a factor of 1,000 or even more. So in this case, we want milliliters to go away. And sometimes students don't like working with really small numbers like that 10 to the minus third. So I'm going to say that 1 liter is 1,000 milliliters. Going through this calculation then, we get 4.6 times 10 to the minus third liters. Couple of things to sort of think about. When we're talking about the sugar cube on the right side, that's kind of our way of thinking about ballparking things and predicting what we think might be a reasonable answer. That's going to become an important skill to think about, because ballparking an answer will allow you to then use your logic hat. So that's sort of the second part of this problem, is making sure that we ask, does this make sense? Right? Looking back at this problem here, if we had had the 1,000 on top, and we had ended up with an answer that was 46,000 liters, that wouldn't have made sense. If we had a tiny little 4.6 milliliter, about 5 sugar cubes worth of volume, would that really be 46,000 liter bottles? No, that wouldn't make sense. So have your logic hat on. Don't always assume that the calculator is going to know exactly the right thing to do. You have to use your own intuition as to whether or not something is the correct answer. All right, more quickly now, moving on to the second part of this problem, which is to convert this 4.6 milliliters into cubic centimeters. And this utilizes a unit conversion that's going to be an important one for us to walk between volume in milliliters and then volume in terms of a length, if you will, or a cubic length. So 1 milliliter is 1 cubic centimeter. And this also is important because this is unique specifically to water. So going through and doing this mathematically, we see this does not change the number of our quantity. It doesn't change the value of it. It changes the units. But again, the answer now is 4.6 centimeters cubed. So a very long kind of video here for a very simple problem, but I wanted to make sure to kind of highlight the importance of thinking about the ease which with somebody could make a mistake by kind of doing these unit conversions.